Again, I am with one topic in news: inverse expansion dispute under science and technology. Dispute is regarding the new method to measure Hubble constant. Hubble, a very significant numbers in cosmology, and it explains the inverse expansion. So see, inverse expansion dispute, science and tech. Why I have chosen this topic? It's in news, and new method to determine the Hubble constant. The inverse rate of expansion is in dispute, and we need new physics to solve it. Right? In news, and this is the fact. Next point, Hubble constant, a very significant number in cosmology, and it explains the expanding nature of universe. So is a value critical in understanding the universe expansion rate. This is the point. See, you can note down as well. Hubble's law and the expansion of universe. Here is an expression: V is equal to h into d, where V stands for the velocity of recession, separation of the two galaxies, and d is the distance between the two galaxies. H is a constant called Hubble constant. This is the law, and Hubble is the name of the physicist. You can see the fact here too. And just I told you, it's in news, and new method to determine the Hubble constant. And it's news because the scientists from ICTS Bengaluru, IUCAA Pune, UCSB California, Santa Barbara, these scientific institutes or organizations have proposed the new method. See? Now, ICTS, International Center for Theoretical Sciences, IUCAA, Inter-University Center for Astronomy and Astrophysics, and UCSB, University of California, Santa Barbara. So this is abbreviation: ICTS, International Center for Theoretical Sciences. Next, IUCAA, Inter-University Center for Astronomy and Astrophysics, and UCSB, University of California, Santa Barbara. Now come to know a very brief fact about the universe. Universe was born out of a big bang, Bada Dhamaka, around 13.8 million years ago. It has been expanding, with its expansion rate. Initially it was rapid, then now it began slowing down. Okay. So universe was born from Big Bang around 13.8 billion years ago, and next point, it has been expanding. And third point, what is the nature of expansion? Earlier expansion was rapid, and then it began to slow down. Okay. However, about 5 to 6 billion years ago, dark energy, it's also very important. There may be question in PT from dark energy, dark matter. You are expected to know the fact. However, about 5 to 6 billion years ago, dark energy caused the inverse expansion to accelerate again. Is the fact? About inverse expansion dispute, it's the dispute surrounding the expansion of the universe centers on determining the precise rate at which the universe is expanding. Next point, the rate of expansion is called Hubble constant. There is a spelling mistake. There should be Hubble constant. See, about inverse expansion dispute, first point is, it is a dispute surrounding the expansion of the universe centers on determining the precise rate at which the universe is expanding. And the next point is, the rate of expansion is called Hubble constant, right? Now, what is the approach of the scientists or researchers from these three organizations? The multiple methods along with the very observation of the brightness of supernova, the very studying the cosmic microwave background, observing gravitational waves for the calculation and analysis of Hubble constant. Again, here is a spelling mistake. Hubble constant. So approach is multiple methods added with brightness of supernova. Next, to study the cosmic microwave background, and next to observe gravitational waves for the calculation and analysis of Hubble constant. However, these methods have provided conflicting results, with some measurements reporting higher values than the others. The area of conflict is there is some measurements that are giving high value. Next, this discrepancy has led to a crisis in cosmology, as scientists seek to reconcile these differing measurements and understand the true rate of expansion. However, these methods have provided conflicting results, mind it, conflicting results. And the point of assertion is, with some measurements reporting higher values than others, this discrepancy has led to a crisis in cosmology, as scientists seek to reconcile these differing measurements and understand the true rate of expansion. Right? New methods for Hubble constant. Now, this will use lensed gravitational waves. Researchers believe that upcoming gravitational waves detectors could identify lensed gravitational waves detectors could identify lensed gravitational waves which can be used to calculate Hubble constant with more accuracy. New method for Hubble constant using lensed gravitational waves. Lensed gravitational waves. Second point, researchers believe that upcoming gravitational wave detectors could identify lensed gravitational waves which can be used to calculate Hubble constant more accurately. That's all for the day. Thanks.